Hello everyone, hope you are doing good. Today we have a new problem, new combination of a hexagonal prism and a cylinder. Let's begin with the problem. Draw the isometric projection of a combination of hexagonal prism, side 25 mm and axis 66 mm, and a cylinder, dia 92 mm and height 54 mm. Cylinder is resting on its base on the HP and a rectangular face of the prism is lying centrally upon circular base of the cylinder with its axis perpendicular to VP. Here, first solid cylinder is resting on its circular base on the ground on HP, and on the upper circular base or upper circular face of the cylinder, a hexagonal prism is resting on its face. So the face of the hexagonal prism is resting on the upper circular base of the cylinder and centrally. Also, axis is perpendicular to VP. So axis of the prism from the front base center to the rear base center, an imaginary line axis of the hexagonal prism is also perpendicular to VP. So this is the final position of hexagonal prism, which is resting centrally on its rectangular face upon the circular face of the cylinder. Now centrally means the center of the rectangle or center of the rectangular plane of the prism or rectangular face of the prism will be on the upper circular center of the cylinder. So first we are required to project this cylinder, and we will start from its circular base. So we have to project a circle along first and second iso axis or on the horizontal plane of isometric axis. The diameter is 92, so we have to take ISO of 92 for construction work. So marking limits of ISO 92 along first and second iso axis. You know the process. First, we are assuming that this circular base of diameter 92 is a part of a square, or the square, which is helping figure or closing figure of the circular base, is to be projected along first and second iso axis, and the diameter 92 is given to us. So marking limits of ISO 92. Now we have all four corners of the helping square. Now from all four corners, drawing lines for generators, or drawing vertical line for length equals to height is 54. Again we have to take isometric length corresponding to 54. So drawing vertical lines of length ISO 54 from all four corners of the square, and then drawing lines joining all four corners. So we have the upper base or upper helping square. Now on both the squares, on bottom square and upper square, we are required to project circle or circular base. So starting from upper base, first step, drawing lines joining opposite corners of the square, or simply we have to draw lines from these two opposite corners for which the length of the diagonal will be larger. Next, we have to mark all four midpoints of the square. These are midpoints, 92 and 54. Okay. Right. And then from midpoint to corner, from midpoint to opposite corner, we have all four centers. First center, and this is first radius, first part. Second center, and this is second radius, second part. Third center, third radius. Fourth center and fourth radius. Okay, again repeating the process for bottom base. First, we have to mark all four midpoints of the square, then diagonal, and then from corner to midpoint, corner to midpoint, corner to midpoint, and corner to midpoint. First center, second center, third center, and this is fourth center. Now, we know that only front portion of the bottom circular base will be visible. So from first center, say this is first center, this is radius, first part is visible. Now from second center, this is second radius, only half portion or half part of this circular arc will be visible, and after this point generator will dominate. Similarly, this is the center and this is radius up to the diagonal, and then generator will dominate. So this is complete projection of the circular base, lower base and upper base. So the first solid cylinder is ready. Next, we have to show solid axis and central lines. So drawing lines parallel to first and second isoaxis from all midpoints of the square for upper base and for lower base. This is the center, first center, and this one is second center. And then joining these two centers, we have to draw solid axis of the cylinder. Now, the hexagonal prism, second solid hexagonal prism, is resting on its rectangular face on the upper circular face of the cylinder. So this part or this face of this prism is lying on the upper circular face. It means we have to mark this rectangular face first on the upper circular face, and we know that the size or side is 25 and axis is 66. So a rectangular face of size 25 by 66 will be on the upper circular face. Now we have two options. First is we can project its rectangular base and then we will complete other construction work, or we will generate complete prism, or we can start from its helping figure. We will project its first base and then second base, and then we will complete its projection. So here I am starting from helping figure. So first, drawing a regular hexagon of size ISO 25, and then enclosing this hexagon inside a rectangular box by drawing lines parallel to and perpendicular to first base side or from the reference side. This is my reference side. So drawing line parallel to first side from these two end limits of these two sides, and then perpendicular from remaining corners. Size of the hexagon and size of the helping box. Are size is 25, x and y. Next, for locating center of hexagon or hexagonal plane, drawing lines from opposite corners. Common intersection point is the center. From reference space, y dash. Now drawing center lines from the center of hexagon in the helping figure. Okay. Now if we assume that this hexagonal face is a part of this rectangle, then we can also assume that the prism, hexagonal prism, is also a part of helping cuboid of size x by y by 66, because axis is 66. So we can assume that this hexagonal prism is a part of cuboid of size x by y by the length of the axis. And now we are going to project that cuboid first on the upper circular base. So the size of the cuboid or size of the face of the cuboid will be x by 66. Now from the center, now we have to mark limits of half of 66 along second center line and half of x along first center line. So marking limits, half of x here, half of x, and for axis or axial length of 66, here we have to mark half of 66 is 33 and 33. Now we have all four corners of the base or of the helping face of the cuboid. So drawing lines parallel to first and second center lines from these points. Right. So this is the face or rectangular face of the helping cuboid. Now the side of length x is projected here. So from these two corners we have to draw lines parallel to third or vertical axis for length of y. So from all four corners, drawing lines parallel to third or vertical axis, third or vertical axis, and then drawing lines joining these points, we will get the upper face of the prism. Now we have the cuboid, closing cuboid for the prism. Next, we are required to mark all corners of the hexagonal prism. See, these points are A, B, C, D, E, and last is F. So from the first corner A, from the first corner A to B, from A to B, then corner to C, corner to C, corner to C, this is C, upper corner to D, from topmost corner to D, D to E, D to E, this is E, and from upper corner to F, this is F. Again we have to repeat this process for rear base. First point A to B, A to B, A and B, then C vertically, F vertically, E and D. So these are 6 corners of rear base. Now, in the last step, we have to show all visible sides and generators of the hexagonal prism. So front face is completely visible and these generators are visible generators. So starting from front face, showing all visible sides of hexagonal base first, and then corresponding generators this is visible side, okay, and these sides are hidden sides, so no need to show visible or hidden or partially visible sides. So this is final complete projection of hexagonal prism. Now second solid, okay, so this is complete projection of the combination, and we have to locate centers of the front and rear base for the hexagonal prism by drawing lines again parallel to first and second isoaxis. Front base, and from midpoint to the midpoint, and through these corners. Okay, now from rear center to front center, solid axis. Okay, right. Dimensioning here, generator or axis for the prism, side of hexagon, height of cylinder or circular slab, and diameter, dia of cylinder, diameter 92 height 54, axis 66, and side 25. Direction of viewing or direction of observation. For this combination, we are observing from this side because axis is perpendicular to EP. So this will be the direction of observation. And last, naming of helping figure and final answer. So please write these headings in single stroke letter writing. So letter height of 5, 8 or 10 mm. There is a small mistake. Extension line for generator will start from the center of the front hexagonal base. So this is the length, or this is the dimensioning line for the axis of the prism. Now I'll request you to please draw this problem on your sheet, indicating direction of viewing, do all dimensioning, write headings, and if you have any problem, any doubt regarding this question or any other problem or topic in engineering graphics, please write your comments in the comment section. Thank you.